Hi and Assalamualaikum to my lecturers. Today we will be showing about our project assignment for the microcontroller. First of all, our team consists of 2 persons, which is HIDAYAH and me, Farhan. So, our project is about home outdoor lighting monitoring system, where the system is a smart home application which is quite popular nowadays, especially among the youngsters.
The first statement that we want to tackle for this project is where the user need to manually switch in the light on and off of the outdoor lamp. This is quite critical in case of the user went for holiday or not around the house, and it can cause waste of electricity for the user. So, the objective of the project is to make a system where it can turn on and off the outdoor lamp automatically, and then the system can send a notification and can be monitored by the user. So, how does the system works? So, let me explain you. The system works by using an LDR sensor that can detect the presence of the light of the surrounding. For instance, if the outside is dark or at night, the LDR sensor will detect there is no presence of the light. So, the system can turn on the light automatically and vice versa. So, what are the component material to make this project works? We are using an LDR sensor to detect the presence of the lights, LED to imitate the outdoor lamp, a Wi-Fi module ESP8266, and STM32F103 microcontroller for the data processing. So, the data that was processed by the STM32F103 microcontroller will be uploaded into TeamSpeak IoT platform for the user to monitor the system. Next, I will give to HIDAYAH to talk about our component and how our system function.
Hi, my name is HIDAYAH binti Halim, and I will explain more further about the designing and developing this system.
This is the schematic diagram for this home outdoor lighting monitoring system that connected with STM32F10368 board, or called Bluetooth board. As shown in this diagram, the LED is connected at pin 13 STM32 board, and LDR sensor connected with pin AO. And lastly, for the Wi-Fi module ESP8266, the RX connected to pin A9, then TX connected to pin A10 on the board. Is the hardware connection on the breadboard. As you can see, this is the LDR sensor, and it is connected at pin AO on the STM32 board. And for the anode leg, for the LED, it is connected at pin 13. And for the ESP8266, the RX is connected to pin A9, and the TX is connected to pin A10. Okay, let's start with our main agenda in this assignment. Okay, first thing first, we need to do to set the debugging, which is the serial wire on the SYS that will enable the serial communication for the computer and the STM32 board. In my case, I use Blue Pill STM32 board that will need to setting up the RCC mode for the clock using the crystal ceramic resonator. Then select the USERT1 to connect the ESP01, ESP8266 to STM32 board. Then put the mode for the asynchronous. Then check the baud rate. In my case, I use 115200 bits per second because it matches with my ESP01. And to enable the connection, select NVIC settings and tick on the enable USERT1 global interrupt. After setting this, go to the ADC1 to setting up the analog pin. we choose IN0 on the mode. This will make AO for STM32 as input for the analog current. Then go to the parameter settings and go to the continuous conversion, then enable it. Zoom in the pinout view, then we have to select the PC13 to setting up the output of the LED in STM32 board. This will make the C13 pin on the STM32 board. Then go to the clock configuration. I used to select the maximum clock to 72 MHz. Then we need to save the project and it will generate the codes. Or before that, we need to go to the NVIC, which is a nested vector interrupt controller. Okay, click to the NVIC. Okay, so at here we need to make sure that the priority of the system take higher than the user1 global interrupt. This is the connectivity from STM32 for the ESP8266 Wi-Fi module. This will make the looping of the program will skip if data available, and it will go through the next function of the system. Then save the project and it will generate the codes. I have referred this step from Dr. Sani in lecture class, and also from the controller stacks website, also the YouTube video for the reference. I used to import the files from the controller text website into the SRC folder and also INC folder, which is for the ESP.datalogger.hn.c, also the UARTringbuffer.hn.c. Then go to the UARTringbuffer.c and go to the line 21 and copy all of this. Okay. Then go to the interrupt.c and paste it on the line 55. And scroll down, go to the line 20x and enable the UART_SR in the column and WART1 and disable the line here. Next, go to the main.c and we need to include the ESP.datalogger.hash. This is the library that we want to use. Then we need to paste the function that we copy from the UART buffer just now, and this is the function to get the ADC value. This is we want to appear in the ThinkSpeak, and go down. This is the function for to insert the Wi-Fi SSID and also the password. Then these are the lines in the codes where the sensor detects when it turns dark, and it will turn on the LED with a delay by 15 seconds if the ADC value exceeds 60. And this is the fastest allowed time for ThinkSpeak IoT platform. Else, the lines in the codes where the LDR sensor detects light, it will run in the normal connection. Then put the API key from the ThinkSpeak in this line to send all the data to the ThinkSpeak. Okay, that's all the program on this IDE workspace. Then do the incremental build, and after getting the 0 error and 0 warning, then do the debug for this project. Okay, let's see the result of the functionality. This shows the sensor detect the light from its surrounding and the LED is turned off So when we block the light at the sensor, the LED will turn on and the ADC shows it at more than 60 to light up the LED. So this is when the ADC is less than 60. So let's see the LED. It turned off because I exposed the sensor to the light. Okay, let me show the result that appear to ThinkSpeak. As you can see, this is the on-off lamp option. This show that the LED turn off and on. This is the when the LED is turned off, and this is the LED is turned on when it's not getting the light. And this is the if condition with field 1. If field 1 is greater than 0, it will turn on the LED in 15 seconds. And this is the field 1 where the data from the project is collected. That's right in here. When the data shows highest than 60, it turns on, and vice versa for the less than 60 ADC. That's all from us. Thank you, Doctor, for spending your time to evaluate this video. Assalamualaikum.